Now I want to review something from the quiz, which has two purposes for being on the quiz. One, not all of you had this question, because the quiz has some random generation of questions in there, so not everybody actually has the same questions on the quiz. I need to step out of the camera for a second to get a whiteboard marker, which evidently I didn't prepare by having it in my pocket. So hold on just one second. So I'm back. So there was a problem on the quiz. Okay, now that problem, because of the random generation of questions, was not a problem that everybody had. But I want to go over it because it's very important for two different reasons. One reason it's on that quiz is actually so that I can talk about it now after the quiz, because you're ready for the second round about lean production and world-class manufacturing. Notice I do that a lot. You know, I get you to a certain point, you know, load you up, have you struggle with something, and then I drop it for a while, and then I come back with sort of a close off. And that close off usually brings things together for a lot of people. So here is the problem. The problem was basically you had a production process that had 2 minutes. Well, doesn't seem to be a lot of ink in there. Let me switch. This is green, not black, but it's a fresher marker, so it probably should work a little bit better. So we basically have 2 minutes per item, and we have a lot size. It says lot size 100, so you have a lot size of 100 items. Okay? And I asked 4 questions. I didn't ask a philosophical question. They were just fact-based questions about the numbers. I didn't ask for an assessment or an analysis. So what I said was, the first question is, how many minutes will that lot be in that station that has these? And the answer is 200 minutes. This one you can do pretty much in your head by observation. Most people can do that. We had 2 minutes per item times 100 items. Okay? And that's going to equal 200. Okay, what is it going to equal? 200 what though? Okay, we'll come back to this in a minute, but from this second forward, anytime you write down a number in this class, you have to completely document the units, or it just doesn't exist. So we have 2 minutes per item times the number of items. So thinking back to high school, you know, physics, which is where I learned how to do this, the items cancel, and you actually have 200 minutes. Okay? You might think of this as a goofy thing I'm talking about. Trust me, you will not survive Chapter 7 or Chapter 10 if you screw this up, because the level of complexity becomes very high in terms of multiplying things where the unit definition changes. You'll have an entire page where you'll set up the equivalent of this 30, 40 times. And if you have it misaligned, meaning you don't have the correct ones, or if you don't do the cancellation properly and your end units aren't right, you got a big problem. And it also is, you know, I'll get to the close off bit. This is a life skill. In the future, when you're an analyst, when you're a decision maker, one of the biggest stumbling blocks I've ever seen is people look at situations and they can't figure out how to get to an answer, because mentally they don't quite line up the facts properly. And one of the keys is actually knowing in detail how to define the things you're dealing with. Okay? In this case, it's not 2 minutes, it's 2 minutes per item. By going to that next level and being precise about what it is you're doing, it actually gives you a huge amount of insight into the decisions that have to be made, and this problem will show us why. The next thing I said was, okay, you have a lot of 100 units. How many minutes is one unit in that process sitting there with no work being done? You can do that by, you know, just observation. You can say 198 minutes, because if it's in there for 200 minutes, right, And then you're working on it for 200 minutes. So total time minus unit processing time, or item, equals 198. Because total time is this number, 200 minutes. That's the total time for the entire lot. The item process time, how much for each item, minus 2 minutes, equals 198 minutes. Okay? Most people got these first two correct. For the second two, not everyone was successful. I think they probably knew what to do, but the number that they were seeing spooked to them a little bit. So next question was set up. It said somebody's thinking about a new metric called item minutes. Instead of items and minutes, we're going to have item minutes, and that's going to be the number of minutes that an item is actually in the station. Okay? And the question is, how many total item minutes exist for this lot of 100 items? The computations, when I put them on the board, the computations are dead easy baby stuff. But having the insight, it would take a lot of focus to come up with this. Okay, you'd have to stop. You know, you can all do it, but you're going to have to stop and focus. When I do it, if you haven't seen this question, when I do it here on the board, you'll say, "Oh, that's easy. Trust me, this was a question that was as difficult as the other questions on there." But the answer looks simple: 200 minutes times 100 items equals, now this is where people got spooked, because this is a giant number. 20,000 item minutes. And that's the real answer. Also, a little bit of a side note here. For the most part, you use the international standard for numbers and units, which would be to use a space, not a comma. This is a little bit, I do this in this class to get you used to the idea that there are alternate ways to even do numbers. So this is like 2-minute side lecture here. So the international standard is this plus comma 00. It's not exactly the way they do it in Quebec. But if your company wants to bid on a job from France, let's say a French company is putting out a proposal and they say, we want you to bid on this. If you want to bid on it, you have to actually send in a bid and have the spreadsheets and supporting documents in the standard numeric form that they require in that country. And so even things like the numeric form are, like you may not have ever seen a different numeric form, but there are several of them out there. And you have to be flexible enough to be able to shift back and forth. There are spreadsheet assignments, obviously we're not doing a second spreadsheet assignment, where I say you have a company from India and you have to, use Indian standards for disclosure. Even though you're disclosing, or in your request for a proposal, it's Canadian dollars, you just have to use the standard Indian numeric display, which is even different from this. Okay, some of you guys will know this, especially if your family is from India or Pakistan. They still use it. They use this, which is they don't use groups of 3 and then the difference. They actually use the first group of 3,000s. Then they have 2 zeros and a comma, and that's called 1 lakh. So lakh, L-A-K-H, means 100,000. So they don't do thousands, millions like we do. They do thousands, 100,000s, then hundred thousands. So lakh, crore. They have a whole different system. When you look at it, just Google India financial statements. You'll see that actually, instead of the numbers even looking like this, the international standard, in India, you'll see numbers like this. Actually, they use the comma in India. That would be an Indian disclosure for numbers, which is they have the thousands like we do. Whoops, I put a comma there. In India, they use the commas like we do, and they use the decimal dot like we do, but they use the divisions in a different way. So they would have decimal dot here, the thousands, but then this is the Lach, right? And this is Crore, right? If you want to do business there, you got to do it their way, right? Or, if you want them to give you their money, you got to do it their way. So I do this a lot in class and in assignments. You'll see I use this partially, actually mostly just to get you used to the idea that there's more than one way to do that. So the answer here is 20,000 item minutes. We're now back to the class. And the final answer was, when the lot is in the station, how many value-added minutes are there? And the answer you can do, it's actually the same answer here, because these 2 minutes, those are value-added minutes for each one. How many value-added times? 100 value-added minutes. So the answer here is 200 value-added minutes. And you can get, it's the same computation. You just add the, in the description, you would add the concept of value-added. So here is actually the computational proof of the impact of lot sizes. And it's ugly, ugly, ugly. Because this is total time available. Now, you're going to have to stare at this for a bit, because really we're talking about, in real time, there were only 200 minutes. However, this is what we had paid for. When you buy an item, but when you buy a piece of raw material, you're paying for the ability to transform that into something valuable. And what we're saying here is, you actually had raw material sitting around with nothing happen to it, nothing at all, for 2 minutes. And you had that 190, and you had that actually 100 times. So what we have is, this is actually the total amount of stuff that you bought by buying a piece of raw material and having it sit there. This is what you actually did with it. So now the next part I did not ask. That was set up so that those of you who did this would see this. And I could put it on. The next thing is, let's make a metric and see how efficient we were. And actually I realized when I'm doing this here on the board, in some people's quizzes, when you get them back, in the comment section, I've made notes about what your errors were. It happened a couple of times. I wrote down the answer here when we do the division is 1%. I wrote it down as 10%, and I wrote that as my answer. So in some 1 or 2 cases, I actually wrote the wrong answer in the comments. You got the wrong answer. I wrote a different wrong answer. When we look at this, we want to take, and this is now chapter 11 material. We're going to form an evaluation method, like an evaluation metric. And what I want to do, I'll draw a line to show I'm doing something different here. I want to take value added over total. Okay? That would be the appropriate metric. I don't want to put value added over bad time, which would be the 198. 198 is the non-value added time. Okay? We don't want to use that. We want to get our relative value added efficiency. So we want to take whatever was value added. In this case, we have item minutes divided by total item minutes. So how many value added item minutes did we have? 200. How many total? 20,000. %. So we have actually used only 1% of the resource that we bought because we have a lot size of 100. If you go, and I want you to do this on your own, I'm not going to do it here. Go and recompute this index with lot size 1. If you have lot size 1, how many non-value added minutes do you have? 0 in the station. You might have it somewhere else in the factory, but in that station you can have 0 non-value added minutes, meaning that over here your value added is 200 minutes, total is 200 minutes, that would be 1 or 100%. So notice, the whole idea of lean production is something we could have found without knowing anything the Japanese did. We did not have to learn this from Toyota, from anybody, and it's probable that there are some companies or some places in Europe or in the United States or Canada that sort of figured this out on their own a little bit. There is some evidence of a similar system to, it's not similar to everything you learned, but just that one piece of saying lower the lot size. That was in the late 1960s, a guy in Texas came up with something called SIS. You can Google it. I think part of the reasons he never went anywhere is somehow he lost a giant lawsuit on not related to his business. Short interval scheduling, just SIS. He developed this. He started down a certain path computationally. What he did was, without doing any of the quality aspects, without mushroom ideas, without thinking about using the group, he just focused only on the idea of changing the lot size. He called it short interval scheduling, and it was either lot size or time intervals, either one. And he showed pretty clearly that it worked really well. And it sort of died. It never went anywhere. Somewhere he couldn't lift it off. So there was information out there, and if you ask the right question, even before we knew anything at all about world-class manufacturing from Japan, if you asked the right question, you could have come up with this answer, and you would have seen this almost automatically. And this would have told you, I ought to think about pulling my lot size down. The part that's missing here is holding cost, storage cost, and moving cost. When you put that in, smaller lot sizes still are better in most cases, unless your move cost skyrockets. But notice you have to, if you want to start from our traditional top-down, manager-led, computationally driven approach, you still could have gotten there, except if you're in the box, you don't even ask this question. Another aspect is to ask this question and answer it, you have to approach your arithmetic like this. Notice this bit, okay, of arithmetic, meaning being precision with exactly what the numbers were. This is what allows you to correctly do the computations that you do, that would reveal this analysis to you. And anytime you show 1% value added, use of your resources, that would get anyone's attention. But they never asked the question. And they never had the mental approach that would even cause them to set up their internal analysis using precise arithmetic. So doing this has saved me so many times. It's gotten me so much leverage in my career, because often I'm the only one out there. Like when a problem comes up, mentally, I automatically do this sort of rigid thing. And actually, I learned it in high school from my physics teacher, Mr. Bernstein, who I'm sure has long passed away, because when I had him, he was younger than I am now. And I wasn't too keen on him at the time. But also, I was a terrible student in high school, really genuinely awful. And I just wanted out of high school. It's like whatever's the minimum I can do to hit the road. But this guy Bernstein, on those physics tests, you had to write, if you put a number, you had to write it out like this, and you had to do the proper cancellation of units. I swear that's the only thing I learned in high school that I ever used again, ever. Now, it's probably not true exactly, but it is definitely the true feeling that I have that I cannot remember ever learning anything else in high school that I ever learned, you actually used again. And this, the logic meaning of setting up actual equations and looking at the pieces in a really granular detail, I've used that all the time. And it really made me a much better analyst, mainly because I made the problem clear from the beginning, instead of waffling around and having things like just saying 2 minutes. If you just say 2 minutes times 100, your answer is still 2 minutes, but you don't really see the building blocks of where that comes from. That disables you. It puts you in a box of not really following up on the right question. So, 2 things that we just did they're independent, they're a core part of this class. One is, from the point of view of world-class manufacturing and lean production and all that stuff, whatever you call it, this is the quantitative or computational proof of the impact of lower lot sizes, just in time, whatever you want to call that, but lower lot sizes. I always wait until after the exam to go over this with you, because I need that fresh brain. For most of you, seeing this will give you a little bit of an aha moment, because it'll take a lot of pieces and pull them together in this tidy and computational way that you might be more comfortable with. Maybe not for everybody, but for most of you, this will be the wrap-up. Second thing is, we introduced this idea of expressing all numeric forms. So from today, this very second in this class, you cannot give me a number without this. I'm going to do to you what Mr. Bernstein did to me, and say that I just won't accept. Like if you put a number down and it's not fully described, in in that science sense, I'm just going to not accept it. It's just going to not count for anything. Okay? An exception would be, and this is actually not an exception, if you're doing a journal entry, the journal entry is described based on the fact that it's in column format. It's in a debit and credit format. So you don't have to do that for journal entries. But anytime if you're documenting how you computed something that goes into a journal entry, you know, you're showing your work, quote, anytime you show your work, you have to show it like this. You're not going to like this, but it is going to save you. Because I mentioned this already a few minutes ago, when you get to chapter 7 and chapter 8 and chapter 10, you will be sunk with the complexity unless you right now start exercising the mental muscle of controlling complexity. Because you're going to have something like this on the page. This, when I say this, you're going to have something that's roughly looking like this on the page 20 or 30 times, but they're not, each one is going to have a different denominator and a different numerator. So it's not going to be minutes per item all the way down. It's going to be, you know, kilograms per liter, ounces, grams per liter, hours per liter, hours per object. It's going to be one after the other. And the numerators and denominators will be different. And if you just start putting numbers down there, what you'll do is you'll put this number down, and then the other number that you put here, you'll actually go, because there's so much going on, you'll pull the wrong one off. And you will have these mismatched. And your number here will be from, you know, like outer space, because you're multiplying things that are the wrong things to multiply. At this point, there's no, I just have to walk away and say no points, right? Because you haven't shown me that you actually got the thing wrong. Now, or excuse me, you haven't shown me that you knew where to get the number from because you haven't documented your thought process. Now to the extreme, actually, if you have this correct and this correct, but somehow you copy down a wrong number here, there's no points off for that. Because I'll assume that if you had a spreadsheet, it wouldn't copy the wrong number down. But I would be grading primarily your logic and your understanding, and I will see your entire logical thought process through the item, the numeric descriptions. Okay? So this is a magical thing to learn and practice, you know, from this day forward. Like I said, this has saved me so many times. It's given me so much leverage in my career, a cost analysis, and you know, in different situations. It doesn't matter what the situation is. Manufacturing, service, restaurants, hospitals, it's all the same. If there's something that you're going to count, it's going to have units. And when you if you properly identify those units, it actually almost, a lot of stuff just solves itself. Because if you walked into somebody with just these answers, right, and they saw this down here, meaning the 1%, you wouldn't have to try and convince them that that was bad. They would figure it out by themselves. You might help them to figure out how to actually change it, but you're not going to have to say, oh, this is bad. This story will tell itself if you actually get this right. And a huge part of it is telling through numbers with the correct units what the story really is. So that is coming to the end of lecture 7A. We reviewed a little bit of class, you know, some of the changes in the class dates, class material, the purpose of the spreadsheet and how we're going in cycles. So that's a technique you can now see I use in this class quite a bit, is I bring you part way, stop you, and then come back for a short little, you know, tidy up. My experience is that solidifies things and gets you ready for the final exam and other things a lot better. And we also then introduced this idea where we closed off some of the computational thinking of the world-class or lean kind of production approaches. But we also introduced this idea, which is a life skill. You know, a life skill about any type of analysis you do, whether you're doing lean, world-class, traditional, or, you know, something you made up. Granularly identifying units will just save your life over and over again. And with that, we'll close off. And in lecture 7B, we'll go into accounting, you know, journal entries, and the accounting system itself.